and then try to do the practice test. Okay, disable my camera, and of course, and share my OneNote. Okay, this was the test answers, I guess. Okay, so we're gonna add a page. We're gonna answers to the practice test 4. So quickly we'll do well this test. Okay. The test covers, or rather, test 4 covers sections 20.5, 21.1, 27.1 up to 27.4. 5 sections. Okay, so practice test now. Practice test 1. Practice test 4. Number 1. Solve. These are solve for x 0 less than or equal to x less than 2 pi. A 4 sine squared x minus 3 equals 0. This is like, these questions are section 20.5 questions, right? There are a few of them. So in doing this, what we do is just we solve like any function, any equation. So 4 sine squared of x equal to 3. You know, when we're solving, we try to isolate x. So sine squared of x equals 3/4. I'm cleaning. I'm heading towards to write x equal to isolating x. So obviously this is a square term, so sine x equal to plus or minus root of 3/4, which is the same as plus or minus root 3/2. So I have two equations. One of them is sine x equal to root 3/2 positive. The other is sine of x equal to minus root 3/2. Sine of x equal to root 3/2. Of course, in here, x is x reference, and that is if you can take sine inverse of root 3/2. I know if you don't want to bother, if you don't want to bother, or if you don't remember what it is in terms of pi, this is sine of 60 degrees is root 3/2. You know, sine of 60. So you know that x reference is pi by 3. 60 means pi by 3. But if you don't remember this, and if you haven't practiced of remembering those angles of pi, then what you could do is second function of sine of what is it, root 3 divided by 2. You will get like 1.047 to 3 decimal place, if you will. So first of all, the sine is positive. This is positive, as you can see. Sine is positive on the first quadrant and on the second quadrant because y is positive. Sine function has a sine of y. So this is positive in here. All right. So this is actually the first quadrant angle. The second quadrant angle is pi minus your reference angle, which is pi minus pi by 3. Well, if you can make them of the same denominator, 3 pi over 3 minus pi over 3, you will get 2 pi over 3. Or you could say if you have if you have been doing with decimals, you would do pi minus 1.047, really. So this is actually the same as uh, 2.095, kind of. So that angle is equivalent to that, you know. So we've got two angles as solutions. On the second one, we're going to look for which quadrants that this is satisfied. The sign is negative when y is negative. Sign always follows y. So sign well, y value is negative here. It is a boundary point of these two quadrants. So therefore, we have one on the third, one on the fourth. The third quadrant angle is pi plus your reference angle. Pi plus your reference angle, which is pi by 3, which is equal to 4 pi by 3. That's an answer. Or you can say pi plus 1.047 in decimal, and you get 1 plus, no, pi plus shift pi plus 1.047 is 4.189. Okay, this is like an alternative. It's not an answer. This is good answer. Okay, for the next one, you probably write with some. So the next one is what? It's 2 pi minus, see the whole thing minus that. So minus pi over 3, which is equal to 6 pi minus pi over 3, which is 5 pi over 3. That is another angle. So again, if you have a problem with the pi, if you're working on 2 pi minus your reference angle 1.047, I will accept the answer, you know. It is 5.236. Okay, therefore solutions x would be simply I will go pi by 3. I will take the values of in terms of pi. But if you gave me answers as 1.047, 2.095, and 4.189, and 5.236, I would accept these answers too. I wonder if I'm recording. Yes, I am. Okay, so that's the first question. The second question is actually if you have tangent of x plus 1 equal to 0, what is x? So tan x is negative 1. This is easier. So, well, where is tangent negative? When x and y. See, tan of theta is y over x, as you know, opposite over adjacent, you know? That's tangent. But when are y and x opposite? Because we want negative. We want negative. So if either is positive or negative, or the other is negative. So that happens in the second quadrant and in the fourth quadrant. Here is y positive, x negative. Here is y negative, x positive. So these are the two. So therefore, x reference would be simply, of course, this is pi by 4. You're going to say second function tan of 1, you will get 45 degrees, which is 0.785. Therefore, that's not an answer. Mind you, this is not an answer because I don't have a solution on the first quadrant, but this is on the first quadrant. So this is not an answer. But the answers are on the second quadrant, which is x. It's pi minus your reference angle, pi by 4, which is equal to 3 pi by 4. And the other one is another x is x1, x2, I could call it 2 pi minus pi by 4, or 2 pi minus pi by 4. Yes, it is 8 pi minus pi, which is 7 pi by 4. So these are the two answers. X must be 3 pi by 4 and 7 pi by 4. All right. Yeah, thank you. You already did it. C have 2 cos squared of x minus sine x minus 1 equals 0. I think this is when you see things like that, mix it up. It's better if you change one in terms of the other, so you can factorize, or you can do like quadratic formula, what have you. So I think this should be changed into, we know from section 20.1 that cos squared is 1 minus sine squared of x. So I will go 2 times 1 minus sine squared of x minus sine x minus 1 equals 0. That's the best identity that we could use, because we want the same angle as x. We don't want a double angle formula or anything. So this is equal to, yeah, 2 minus 2 sine squared of x minus sine x minus 1 equals 0. So minus 2 sine squared of x minus sine x plus 1 equals 0. I can change the sign. We can hit with a negative sign. So it's 2 sine squared of x plus sine x minus 1 equals 0. This is a quadratic equation of sine. Quadratic equation of sine x. So you can factor it the way I do it. I mean, I know I have this method that I use. It gets me quickly to the answer. But you can choose whatever method you know in finding and factoring the trinomial of a quadratic equation. So here is the first product is 2 sine x times sin x. The third product, which is the constant term, is negative 1. So I have to place the negative in the right place. Negative 1 times 1 is negative 1. And then the reason why I chose this to be in this place is because the cross product, 2 sine x minus sine x, giving me the middle term, sine x. So your writing is very important. So if the cross products added together give you the middle term, then the factorization is working. And then when you write them across. So you write them as 2 sine x minus 1 sine x plus 1 equal to 0. Okay, thank you, Wisa. So here we have two equations. As you know, a times b equals 0, a is equal to 0, b equals 0. You do that, 2 sine x minus 1 equals 0, sine x plus 1 equals 0. Then we have two equations. Okay, 2 sine, well, here, sine of x is equal to 1/2. You can tell that, right? You can take the 1 on the right hand side to the right hand side and divide by 2. Here sine x will be just negative 1. So there are two classifications we have to resolve. This is a quadrant angle. It's very easy. It's only one solution. Quadrant. Sine of x is negative 1 when it is 3 pi by 2. So in here, x is 3 pi by 2, positive 3 pi by 2, or you can answer negative pi by 2. For this one, the reference angle is equal to x, of course, because the sine is positive in here and in here. So on the first quadrant, the reference angle is itself. Okay, so it is actually, when is sine equal to 1/2? It's 30 degrees, which is pi by 6. So what is the second quadrant angle? X is pi minus your reference angle. which is equal to 5 pi by 6. 6 times pi is 6, pi minus pi, 5 pi over 6. So I think you're okay with it. Like the first quadrant, second quadrant are found in such a way. On the second category, there is only one single angle because it is a quadrant angle. We don't need reference angle analysis in here. So therefore, x must be pi by 6. The reference angle is part of the answer. This is an answer too. Not only a reference angle, but also an answer. Pi by 6 because the angle falls on the first quadrant. When the angle falls on the first quadrant, the reference angle is the angle or the solution. Pi by 6, 5 pi by 6, and 3 pi by 2 are the answers. What's pi by 6? Remember, I gave you a review. Pi by 6 is 30 degrees. If you're using your calculator in degrees, if you do second function of 1/2, you will get 30 degrees. 30 degrees is pi by 6. Even really, to tell you the truth, even if you on the test, if you don't have to give me in radians, if you prefer in degrees, I don't mind. If you find 0 less than or equal to x less than 360, I don't mind it. Just answer with degrees. So I will change, maybe this is what you see on the test, but if you do it in degrees too, this is also not bad. 0 less than or equal to 3 theta, or x in this case less than 360. If you prefer 360, I mean degrees. Both of them I will mark right. My intention is to check if you are following how to solve trigonometric functions, not only just in radians, but also in any sort, you know. So that's my point of interest. I really don't mind whether you give me in radians or in degrees, okay? All right, if the numbers are okay so far, we can continue. So C is done. I mean, number 1 is done. I will do C, the questions on number 2. Question number 2 is derivatives. Find the derivative of y equal to cos of x to the 5 minus 3x squared plus 7 or b y equal to 6 sine x cos of 4x, d y equal to 5x minus cos cubed of x to the 5. Hopefully, I don't want to go back and forth to the page. I don't want to populate the page either because it doesn't. I want to relax and write whatever I want. So number 2 is find the derivative. The derivative in a simplified answer, and simplify, I would say simply. Once you find the derivative, you simplify. So a of this function, cosine of x to the 5 minus 3x squared plus 7. Just want to remind you the formulas we did. Number 1, d by d, the derivative, okay, d by dx of the cosine of sine of u was cosine of u du by dx. I'll give you the formula sheet. D by dx of cosine of u, just below the test, when you see test 4 on Blackboard, test 4, there is a file, and then there is another entry, formulas for test 4, formulas the test 4, right below it. You can use that file will be added into the test folder. So when you populate this, you can also populate this if you want to save time, you know. So d by dx of cos of u is minus sine of u du by dx. And then, of course, number 3, d by dx tangent of u. We're going to talk about this later on. or maybe I will introduce those later on, right? I think this section is a section of 27.1. These three questions are that. So let's find dy by dx. This is the derivative of cos, because there is no power at all. So we immediately go to derivative of cos. Derivative of cos is minus sign of your angle. The angle is x to the 5 minus 3x squared plus 7 times the derivative of the angle, which is the derivative of that, which is 5x to the 4 minus 6x. Derivative of 7 is not part of, the derivative of 7 is 0. So you can bring this up front, not to confuse, not to multiply both of this, because you can't multiply both of this, because this is under the influence of the sine function, this is not. Okay, so I would simply take 5x to the 4 minus 6x to the front, sine of the angle x to the 5 minus 3x squared plus 7 would be the answer. Okay, so B, you have to stop me if it's not clear. Y equals 6 sine of x cos of 4x. And this is a product rule. What is the previous case? It's the derivative of sine, but this is product rule. The derivative of cos is first a chain rule, I could say. But product rule dy by dx in here, if you consider this as u, this as v, the derivative of u is 6 cosine of x times v cos of 4x plus u 6 sine x times the derivative of v, which is minus sine 4x times 4, isn't it? In here, when we find the derivative of this, we didn't care in the chain rule, because this is x. There is no number multiplying it, or it's not a function. But when we find the derivative of this, we have to be careful about about that 4, because the 4 is the derivative of the inside, which is coming out of the chain rule, right? So if you understand what I did, this is u prime v, this is u, and this is v prime. That's exactly product rule. So this is equal to 6 cos x cos 4x, and then minus 24 sine x sine 4x is the answer. You can factor 6, but there's no use. I don't care really. It doesn't help me anything, so I will leave it the way it is. AB, as it C, I think. So let me see. C is 5x minus cos cubed x to the power of 5. Y equal to 5x minus cos of cubed x to the power of 5. dy by dx, this is again chain rule, or what we call general power rule. So the derivative becomes, bring the exponent up front, right, into 5x minus cos cubed of x to the power, reduce the exponent by 1, times the derivative of the inside. The derivative of that is 3 cos of x squared times the derivative of cos. So this is equal to 5x minus cos cubed of x, and 5 plus 3 cos squared of x sine of x is what we need. To the power of 4. Yes, thank you. Thank you, sir. There is a missing 4. Yeah. So again, I repeat the process. Bring the 5 up front. write the base, reduce the exponent by 1, times the derivative of this thing. The derivative of 5x is 5. The derivative, what is the derivative of cos x cubed? You know, the derivative of that is 3, write the base, reduce the exponent by 1, so 2, not in here, not in here. Either you use brackets or you use here inside, times the derivative of the inside function, which is minus sine x. That's what I got here. No, that's what I got here, really, the derivative of the inside. All right. Right. So next question is, these are the questions of, d sine 4x over cos squared x. D is y equal to sine 4x over cos squared of x. So dy by dx is the derivative of the top, which is, this is u over v. Derivative is u prime v minus uv prime over v squared. We just follow the same old quotient rule. The derivative of sine 4x is cos of 4x times 4, right? Times 4. The derivative is same, times the denominator, cos squared of x, minus the top sine 4x, times the derivative of the denominator. The denominator is cos x squared, the same as cos squared x. So when you find the derivative of that, you get 2 cosine of x times the derivative of cos, which is minus sine of x, over cos squared of x squared, which is the fourth power of cos. In here, I have 4 cos of 4x cos squared x, minus becomes plus, sine 2 sine of 4x cos x sine x over cos squared x, cos to the 4x. Now I think we can it's important that we factor cosine of x from the top. Even we can pull out the 2 if you want. Sine 2x for the back. I don't know if it helps me. I would rather keep it the way it is with the same angle, and then I'll continue. So I have 2 cos x. Yes. Any suggestion? Okay. Let me finish and then we'll discuss about it. 2 cos x, and I have 2 cos of 4x plus sine 4x is in, sine x is in, over cos of 4x. So the...
Sir, I can't see your screen.
Oh, really? Something wrong? Oh, what happened? Even now?
Yes, even now.
Okay, I will share it again as new. Better or?
Yes, sir. There's the screen right now.
Yeah, thank you. Sorry about that. I don't know what happened. So I factored 2 cos x. If you don't, that 2 is not going to help me, but cos x is common. I'm looking forward to cancel the cos from the top and bottom. So this is cos cancel, and you get 3 here. It is 2 cos of 4x. I think the 2 is not necessary, but anyway. 2 cos of 4x plus sine 4x sine x over cos cubed of x. would be the answer for me. I know Wissam suggested something different. Is that what I saw on the conversation, or you're okay with this? Yeah, there is a sine 2x here. If you went, I see there is a sine 2x right here, but it would be a mix of sine x and I mean an angle with an x and an angle with 2x. I think this is preferred. Yes. Do you want to say something?
I was just going to say at the beginning of the formula, sine 4x, I thought that could be a double angled formula to 2 sine 2x cos 2x.
Yes, I agree. Is it Michael? Oh, who is this?
Trevor.
Trevor, sorry. Yeah, it could be, but for the purpose of calculation the angle, say for example, if they say find where it is, like so if you want to solve for x where the derivative equal to 0, if you want to find a critical number, it's not good to change it, and you want an angle which is the same. So Trevor is suggesting we change this into a double angle formula. That's okay. I think it's okay. We can do it. And we can even change this into a double angle formula of 2x. But it will complicate things. It will not get us anywhere, because we still have cosine to the 4x. So I think I would suggest to leave it the way it is and then answer like that. Is that okay?
Yes, thank you.
You're welcome. All right. Because if it's not solving yet, it's only find the derivative. This is the slope of the curve. Slope of the curve. So unless they say, okay, you know, I don't know, if we need to make all the angles 4x, 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 it will be very challenging. You might not even be able successful, you know. So I think the changing in finding the derivative using the identities is useless unless you're solving. I think in section 5 we use them a lot because the derivative is not what they are asking. So we need to have an angle which is consistent, like x, 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 or 2x, 2x, 2x. But on derivative, you're free. Just leave them the way they are. There is no problem. Next question is x squared sine cubed of 2x. Y equal to square root of x squared plus sine 2x. Is that what it is? My mind is sine cubed 2x. Okay, so this is again power rule, general power rule, or what we call the chain rule. So this is x squared plus sine. In fact, if you want to be technical, this means cubed. This is what it is. Another writing of this is this. So dy by dx, it's better, I think, in my opinion, this is actually a better representation than this one. Before you find the derivative, the derivative, you know, we use this power rule, n u n minus 1 u prime. That's what we did. So bring the n up front, write the whole thing as a base. The base is this, the inside one. Reduce the exponent by 1 times the derivative of the inside, which is 2x plus, okay, here is a challenge, the derivative of that. Bring the 3 up front, write the base, reduce the exponent by 1 from 3 to 2 times the derivative of sine, which is equal to cosine of 2x times the derivative of 2x, which is 2. It's very, very continuous work. It's not only, I'll repeat the process. 1/2 up front, right? The whole base without touching it to the exponent, because you got to fix the exponent first. Then find the derivative of the whole inside. The derivative of 2x squared is 2x. After the plus, the derivative will be the derivative of this, which is even complicated itself, right? Cos of 2x cubed. What is its derivative? It is 3 times, right, the base, reduce the exponent by 1 squared times the derivative of cos 2x minus sine of 2x times the derivative of 2x times 2. That's why I have this. 3 cos, oh, did I do that? How did I get cos here? 3, oh, the quotient is the quotient is sine. So 3, right, the base, sine, without reduce the exponent by 1 times the derivative of sine must be cos. I copied the quotient wrong. Cos of 2x times 2. So this is what I should have written. I wrote this cos, okay? So hopefully 3 sine of square sine squared 2x okay. So I'll leave this for you for your practice, you know, because it will help you how we got that, right? So when I raise it, then this becomes, of course, this thing is negative exponent, so I'm going to write it on the denominator, x squared plus sine cubed of 2x square root. That's what it means. So the negative half means. And the 2 is in the denominator. I put the 2 in the denominator. And whatever up there is going to be in the numerator. 2x plus what is here. See, we can bring the numbers up front. Again, 6 sine cubed of 2x cos of 2x is what I got. Yes, 2 is common. Thank you. Thank you. You're right. This factorization is important. 2 is common.
Sure. And the final answer that you have, you have sine cubed 2x. Wouldn't it be sine squared?
Did I copy wrong again? Yes, you're right. This is what I am copying. So it must be second power. Thank you.
Okay.
Appreciate it. Yeah. You're right. I'm copying wrong today. But thank you for the correction. So I have x plus 3 sine squared 2x cos of 2x over 2 square root of x squared plus sine cubed of 2x. You didn't have to write that. You can go directly to the answer as long as you know it. The only problem with that is sometimes you take this away, but you forgot to take away that. So it's better to factor first technically, but if you already know what you're doing, you can skip this step and then write this 2 cancel x plus 3 sine squared 2x cos of 2x over the square root of x squared plus sine cubed of 2x. You get it right? Yes. I know I write too much because I think I'm explaining, but sometimes if it confuses you, you can cut the steps, I think. So next question I want to do, this is section 1. If you remember, this is all section 1 of chapter 27. The section 2 questions will come now. For question number 3, 5 times 3x to the 5. So a 5 10 3x Oh, did I 5 times 3x is a 5? I said. Okay, 3x is the denominator. 3x is a 5, like that. That's why. So this is number 3. Again, the same instruction. Find the derivative and simplify, I would say. Or I would say find the derivative with a simplified answer and give the answer in simplified form. Okay. So a, y equal to 5 tan of 3x the power of 5, I guess. Yeah. So again, we need a formula. Like we have to populate more formulas. Number 3, the derivative of tan of u, we did it. It is secant squared of u times the derivative of u. Number 4, the derivative of cotan of u is minus cosecant, minus cosecant squared of u du by dx. And number 5, d by dx of secant of u was secant of u tan of u du by dx. 6, d by dx of cosecant of u is minus cosecant of u, cotangent of u du by dx. I will add those to the formula sheet. Like I said, we had the first 2 here, we had the first 2 here, and then we got the 4, because this is section 2. They call them other functions, because section 1 was only for sine and cosine. So the derivative of dy by dx is the same thing. We have 5u to the 5. The derivative is 25u, which is tan 3x, and reduce the 5 into 4 times the derivative of the inside, which is, by definition, secant squared of the angle, which is 3x in my case, times the derivative of the angle, which is 3. Chain rule. So this is equal to, and they are all multiplication. I can bring out the 3 and the 25 to multiply, 75, and then tan to the 4 3x, I can write. Tan cubed of, tan 4 to the power of 3x, the same as tan of 3x to the power of 4. I hope you understand me by now. Times secant squared of 3x, that means secant of 3x to the power of 2. They are trying to write this in a way that they will avoid writing the brackets. Hopefully everything is okay. The B part.
Do we have to reach the primary function, like not leaving the secondary function as C?
No, not in derivatives. No, we can
Okay,
leave them the way they are. Not in derivatives. And simplify like the first test, the previous test. We wanted to double check. We changed the tan into sine x over cos x, or 1 over cos x. No, you're not wrong doing so, but you're complicating the function. There are 6 functions from sine up to cosecant. All of them are of equal status in calculus.
okay, thank you.
You're welcome. All right. Next question is y equal to root of, y equal to 7 cosecant 9x cubed. Y equal to 7 cosecant 9x cubed. The power of 2. Can you mute yourself, please?
Oh, sure.
Otherwise, I have to mute everybody. Okay, thank you. So cosecant 9x cubed to the power of 2. All right. So dy by dx, this is b. dy by dx, again, this is well written. There is nothing you can do. You have your u here to the power of 2. Then apply power rule. It's 14 cosecant 9x cubed is the inside function times the derivative of the inside function. The derivative of this. What is the derivative of cosecant? Cosecant's derivative is the last one. Remember that the functions with we start with a c, they all have negative sign. Don't forget that. The cotangent has negative, the cosecant has negative, the cosine too. So, okay. So the derivative of cosecant is minus cosecant of u, which is 9x cubed, cotangent of your angle, which is 9x cubed, times the derivative of u, the angle, which is 27x squared. You have to really do that locally, you know, even though this doesn't matter, but always when you find the derivative of the angle, you always do it with the derivative of the inside. You cannot do it outside because that will, if there is a plus or minus here, that will affect your equation anyway. You got to be careful. So here, all of them are multiplications. There is no problem. So I'm gonna take 27 times 14 up front. So it's 378, and I have negative sign, right? Negative sign, and I have cosecant 1 power and cosecant a second power. I mean 1 power. So when they multiply, they get the second power of 9x squared, 9x cubed. So it's like cos x times, I mean cosecant of x times cosecant of x is cosecant squared of x. That's what I'm saying. Cosecant of an angle times cosecant of the same angle is cosecant squared of the angle, which is that. So what's left? So this is taking care of, this is taking care of, this taking care of, this is, and even the negative is taken care of. Cotangent 9x cubed, and oh, there is x squared. I will put on the front. I don't want to put x squared here because there could be a confusion of multiplying x to the 5. No. That's why I write it as a front multiplier. So this is the best answer, I guess. Negative 378 x squared, cosecant squared 9x cubed, cotangent 9x cubed. C square root of secant 4x. Y is equal to square root of secant 4x, which is written better if you don't like it. This square root for differentiation purposes, the power part is better. This is better. Then find the derivative of that 1/2. Write the base. Take away the exponent by 1 times the derivative of the base. What is the derivative of secant? Derivative of secant is secant times tan. Okay. So it is secant of u, which is 4x, tan of u, which is 4x, times the derivative of the angle, which is 4. So here, this is going to go to the denominator. So here I got 2 square root of secant 4x, right? Because to the power of half means the square root. Oh, I would rather keep it. I would rather keep it because there is secant on the side to the power of 1. The power of 1. So I can add the exponents. So 4 divided by 2 is 2. This 4 divided by this, multiplied by this half is 2. Okay? Secant to the 4x to the power of minus half plus 1 is 1/2. Right? You can add exponents if the bases are the same. So 1/2, and then tan 4x is what I get. So this is actually 2 square root of secant 4x, tan 4x is what the answer is. Okay. And then I got a D, which is y equal to, I think A, B, C, these were like for section, did I say these are section 27.2 questions, these 3 questions. Then section 27.3 are the following questions. I think D is y equal to cos inverse of 5x cubed. Yes. So the derivative dy by dx is, the cos inverse is, remember, I'm going to add a few formulas. I'm going to add then number 7, d by dx of sine inverse of u is 1 over root of 1 minus u squared du by dx. Number 8, d by dx of cos of inverse of u, and this has negative because it starts with a c, negative 1 over root of 1 minus u squared du by dx. Then number 9, d by dx of tangent of u, tangent inverse of u, is 1 over 1 plus u squared du by dx. And the inverses are not exponents. This inverse, this is not exponent, please. It is a notation for the inverse. It's notation for the inverse. It's not a number, not at all. Not -1 is not a number. Okay, it's a notation for the function. So the derivative dy by dx in my case is, it follows this, number 8. So it is minus 1 over root of 1 minus 5x cubed squared, because u is squared, times the derivative of u, which is 15x squared. So this is minus 15x squared over root of 1 minus 25x to the 6th, I can say. You can do the power rule here. 5 squared is 25, x to the 3 to the 2 is x to the 6. Okay, E is y equal to sine inverse of, I think I made a mistake here. I meant 3y over cos inverse of 3y. Oh, I meant x and then x. Change it to x. Y is here, so. All right. So dy by dx is quotient rule, u over v, that u prime v minus u v prime over v squared. So the derivative of sine inverse, as you know it, is 1 over the square root of 1 minus 9x squared times the derivative of 3x, which is 3. That is the derivative of u. What's v? Times cos inverse of 3x minus u, which is sine inverse 3x. Please take it easy and follow me slowly. I'm trying to fill this up. And v prime, which is the derivative of that, which is minus 1 over root of 1 minus the square of 3x, which is 9x squared, times the derivative of 3x, which is 3, over the denominator square, cos inverse of 3x, the whole square. So you can't multiply -1 and 2. You cannot say cos to the 2 3x. I'll take marks, definitely, if you do that. That will defy completely the meaning of the function. So what I mean is, we have the same denominator. We have root on the numerator only, on the top. This is one denominator for both. This is 3 cos inverse of 3x minus 3 sine inverse of 3x over the big division is cos inverse of 3x the whole square. So you know this is what a over b divided by c, which is a over b times 1 over c, which is a over b times c. See, so we're going to multiply these two. So this is 3 is common, cos inverse of 3x minus sine inverse of 3x over the square root of 1 minus 9x squared times cos inverse 3x the whole squared. This is a complete answer. Hopefully you followed me. Is there any concern there? Okay. Now, next question is f, which is y equal to 8 tan inverse of x squared. So the derivative of dy by dx is 16 tan inverse of x to the power of 1 times the derivative of the inside. The derivative of the inside is, obviously, I gave it to you here. The derivative of tan inverse is 1 over 1 plus u squared. So it is 1 over 1 plus x squared. So this is, obviously, this is in the denominator, and 16 and tan inverse of x is in the denominator. Okay, I think these are the 3 sample questions I chose for the third section, and there is G. Where? Let me see. Is that all? Yes. Oh, okay. Number 5 on the bottom is not going to be part of the test. If you have it, please find the derivative. There is logarithmic functions. They are not part of this derivative, this test. Only what we are left is number 4 from the practice test. Number 4, I think we did this in class. So y equal to 0.5 sine 2x, y equal to 0.5 sine 2x to t plus 0.3.
Sir, can I say something? We did this in class, and we have 4 homework questions. They are worthy questions. So
Okay, yeah, we will. I will write it and then I will make a comment. Okay.
Thank you.
Hold on. Yeah. 0.3 cos of t So we did this in class, I think. So I'm asking find the velocity and acceleration. So what we do is we find dy by dt, which is vx, I mean vy. Okay, so we plug t as a given point, 0.4, and then you get, that's the magnitude of the velocity. Okay, for the acceleration, acceleration y, we do the second derivative of y by dt squared at t equal to 0.4 would be the magnitude. So refer to notes on section 27.4 done in class. Okay, what are the questions? So we're done with the practice test. Then I will take your homework if you have any. Okay, homework question is everybody on the same page. We have done this question, right? So you followed me. what I said. So you're gonna double check your notes. Okay, Wissam, you have a question?
Yes, sir. There was 13, like all of them. If just you
Okay.
gave us the relationship only, we can't do the derivative ourselves.
Yeah, that's the part of math which is hard, is to come up the relationship.
Always.
Am I right? Am I right? Yeah. So you okay? We have time, hopefully. Oh, do you have time? You can stay with me a little bit. I have time.
Just the relationship that will gonna help us
Okay.
even to go
Okay.
through them.
So number 12. So number 13. Is it section 847? Oh no. Section 27.4, page 847. I know Trevor asked me number 13. Yeah. So we'll start number 13. Number 13. What is it saying? Find the minimum value of the function. That's okay. Y equal to 6 cos x minus 8 sine x. Quickly, I will do this. You find dy by dx, which is equal to minus 6 sine x minus 8 cos x. You let it 0, and then find the critical numbers. Find critical numbers. Right? Find critical numbers by saying what? Well, what is it we're gonna do?
Tan x will be probably
Yes,
tan x equal to
6/8 or 8/6.
yes.
So
And will be
minus
4/3.
sine x minus 6 sine x minus 8 cos x. Okay, I'll go 8 cos x, right? Right. So
Yes.
it is cos x divide minus 6 sine x, or sine x over cos x would be 8/-6, which is tan x equal to minus 4/3. Is it?
Yes, sir.
Okay. So then the tan is negative where? Tan is negative
Second and fourth.
second and fourth. Tan inverse of so reference x is tan inverse of 4/3 without that. So second function tan of 4/3 is
53.
53 angle in degrees.
Yes, 53.13.
Oh, so it's like
We cannot use
okay,
radiant. Oh, sorry,
radiant.
pi.
Yeah.
We use
Point-
radiant.
Okay. So what is it?
It's 53.13.
Okay.
Do you want
but
it in radian?
in radians, yes. It's 0.927. But
Yes, 0.92729 will be
okay. 0.9273. Then let's take. Right. Then x would be the critical numbers are pi minus 0.9273 and 2 pi minus 0.9273. These numbers are critical numbers. We're gonna test them, and then we're gonna decide which one is. What does they say? Minimum. Okay, so pi minus 0.9273 is 2.2143. You found them already? Okay, what about the second one? 2 times pi minus 0.9273 is 5.3559. Thank you. So therefore, we can test them. We can test second derivative or first derivative, right? So first derivative, you have 2.2143, 5.3559, and then the derivative dy by dx is what? What is the derivative? Minus 6 sine x minus 8 cos x. Minus 6 sine x minus 8 cos x. Then, you know, is it minus, plus, or minus? You did it? Yes, very good. Go ahead, Wissam. So, oh. Okay. So if you plug any number less than, I think I can plug 0 for this one, for 0. So 6 sine of 0 is 0, and 0 is minus. This is
Minus.
negative.
Yeah.
Yes. So I can plug here. Obviously, it's plus, it's minus. You can check it, definitely. Okay. So what they want. So this is negative. This is positive. This is negative. So they want minimum. So this is the minimum value. They want find the minimum value of the function. Okay. Therefore, the function attains its minimum at x equal to 2.2143, and then what? Find the minimum value of the function there. Then take the function y 6 cos x, y equal to 6 cos x, okay, minus 8 sine x. If you plug x to be 2.2143, that's the number, okay? Minus 10? Yes, Wissam. Trevor, you got it? Okay. All right. Very good. Okay, Wissam, is there a particular question or all of them? What's the next one?
Maybe 21. I want only the relationships here. Only. Don't
Okay,
go
what
through all.
is the next question I assigned though?
I think 20 was 21.
21, okay. They gave us a relation then. A point on the outer edge of 38 centimeter can be described by the equation of x equal to 19 cos of 6 pi t, right? Y
Yeah.
equal to 19 sine of 6 pi t, right?
Yes.
Then find the velocity. This is they give us. So dx by dt, right?
What
dy
is
by
it? Okay, the 38. Where we're gonna use that?
Okay, hold on. Find the velocity. Okay. Oh, nothing. That's the name of the wheel. Doesn't matter. They already factored that 38 centimeters in their equation.
Okay,
But
then,
they say, oh,
it's okay.
this kind of car, this kind of,
okay.
you know,
No,
that's
no
a
need
name.
to. Okay, so
Okay.
then
We
no
will
need.
start it though.
Oh,
Quickly,
okay.
I'm
Okay.
not going to do it, but quickly I will do number 25. Okay. 25, you don't have a relationship. We're going to do number 25. Did I assign 25? Yes, I did.
Yes, sir.
Okay, so what is the derivative of dx by dt? It is 19 sine negative, right? Sine of 6 pi t times 6 pi.
6 pi.
Okay, so what is 19 times 6? It's 114 pi sine of 6 pi t. The dy by dt, 19 times 6 pi cos of 6 pi t. The same, this is 114 pi sine of 6 pi t. Then you plug t to be, did they give us t? Yeah, at 0.6, you plug t to be 0.6, and then the velocity they are asking is the square root of dx by dt squared, whatever you found, plus dy by dt squared. That is the magnitude. Very easy, because you're going to find the number here, you put them in here, right? And then to find the direction of the velocity, you find where, well, you will find which quadrant it is, and then theta reference and theta. Is that okay? I think you could do this because this is parametric curves. We've done them in section 2.
Yes.
Thank you. So you can finish this up, theta reference, and then you locate if this is negative, if this numbers, if this based on these numbers, you can determine the location of the quadrant, and then based on that, you find theta reference by dividing the y value of the velocity by the x, and then of course you by adding pi plus or pi minus theta reference or 2 pi minus, you will find the appropriate angle for that. Okay, I think that you can do it yourself. Number 25 is the last question. So a person observer of an object dropped by. So they have a building. Something is dropping from the top of the building, and here is what the location at this very moment. So this is 60 meters from top to bottom, and this is 40 meters, and this is theta. Okay, so this is well, you can derive it. This this is going down at the motion of s equal to 4.9 t squared. This is like in physics, the a free fall displacement equation. It's s equal to half a to square plus v naught t plus plus v naught. So this is 0. It's free fall. This is 0. Ga is 9.8. Then it is 9 point divided by 2 is 4.9 t squared. That's how they got this. This is going through the free fall equation of motion. Okay, so they want if the top of the building is 60 above the person's eye level, how fast is the angle of elevation? How fast is the angle of elevation of the object changing after 1 second? Time is equal to 1 second. So so I think so what is this? This is what? 60 minus s. Do you agree? So therefore, tan theta, I figure out a relationship between theta because they want theta, right? They want the change in theta. So tan theta equal to opposite over adjacent. Opposite is 60 minus s over adjacent is 40. And of course, s is like I said. I wish they didn't give that. Then it would be more challenging question. You would have done that. So, but anyway, they gave it to us. So 60 minus 4.9 t squared over 40 is tan theta, but they want theta. So I'm going to go theta is tan inverse of 60 minus 4.9 t squared over 40. This is the inverse function. Do you see that? Theta of t is this. This is our equation, Wissam. Did you get it?
Yes,
All of
sir.
you, did you follow? Did you follow class for this? It's one of the hardest questions, I tell you. But they made it easy because they gave us the S formula. The S formula is that. So this function of theta is expressed as a function of time t in such a relationship. So we encounter tan inverse, a different function, which we have done the derivative of. So then what do you do? So what do they say? Find what? How fast? So find the derivative then. D theta by dt is what they are asking. D theta by dt is what?
So 1 over 1 plus u square.
Thank you. 1 over 1 plus 60 minus 4.9 t squared over 40 squared. Remember that is what? Your u. Your u is this one.
Du
So I
over
did that
dt.
times the derivative of the angle, right?
U.
So what is that really? 60 over 40 minus 4.9 over 40 t squared, right? Isn't it?
9.8 divided by 40t, right?
Yes.
Minus.
The derivative of this is 0. The derivative of this is bring the 2. It makes it 9.8. 9.8 over 40 times t. I think that's it, right? You bring the 2 up front, multiply by 4.9, you get negative 9.8. Divide by 40 stays there. Reduce the exponent by 1. That's it. So if we plug in, what is t? T equal to?
1 second.
Is it 1 second? Yeah. 1 second, yes. Then it would be easy to do. Then this is 1 over 1 plus 60 minus 4.9 over 40 squared times minus 9.8 over 40 if it's 1 second. So that number is what we're looking for. I got 0.34512 times so yeah, some of you got it before me already. You're good in the computer, like 0.08455. Is that what you get? Yes, excellent. That is, I don't know what they give you in the back. You don't have to be worried. It's the process which matters. I think this is the right process. I tried my best. I hope you followed me. I know I rushed you because there is no time, but I hope you followed me. Is there any comments or any question or any concern you want to say? Okay, Wasim, I got your note. Have a great day, you too. You know, some of you have maybe you have a class, but I'm recording it. You could have left on time and then check the recording. But anyway, thank you, Supadi, too. Bye, Trevor. Have a great day. I'll see you, Catherine. Have a good day. Dima, the same. Dima, I have a question. Yeah, okay. You can stay and ask me, or you can ask me now. What's it? What's the question?
Hi, sir.
Yes, how are you?
I'm good. How are you?
I'm good.
Sir, in practice question.
Yes. Oh, you're. I can't hear you.
Yeah, now?
Now you're back. Good.
Yeah. So in question 2, D, we took 2 cosine x as a common factor, right?
Yes.
Yeah. So
Did we miss it? Yeah.
a practice question, number 2D.
The one we did today?
Yeah.
Okay, number 2.
D. It's.
We passed it.
Yeah. Yeah, this
Yes.
one. Okay, so we took 2 cosine x as a common factor. So the answer should be like 2 cosine
You're
4x
right.
times cosine x.
Yes. Thank
We
you so
have
much.
cosine, yeah.
I got it. 2 cos of 4x times cosine x. There is one factor.
Yep.
Yeah. Thank you so much. Excellent, Dima.
Oh, no problem.
I
Thank
messed
you,
up.
sir.
I messed up, but you can't take marks from me.
No.
You know why? My
Thank you, sir.
professors took marks already. There is nothing left of to take. Okay, Dima. Thank you. Yeah.
Have a good day.
That was a good correction. I really appreciate it. Thank you. Have a great day. Okay.